Hey everyone, I'm here to talk about a shortcut when you're trying to take limits. This will be very helpful on the AP exam at certain points and get you through some questions a little bit quicker. So let's get to it. This is not my shortcut. This is what we call L'Hopital's rule. Guillaume Francois de L'Hopital. He died in the early 1700s, like around 1704, I think it was. And he was only like 42 or 43 years old, but his contributions to math, especially calculus, are pretty important. He worked a little bit with Johann Bernoulli and also Gottfried Leibniz. All these guys were French, and they kind of came up with these things. I think Bernoulli actually was a student of L'Hopital for a while there, and then Bernoulli and L'Hopital kind of got into a little bit of an argument at the end there. You guys can look all that up if you want a little bit more information on that, but Gottfried Leibniz is who we're going to, his contributions we're going to get into in the next month or so. This is just kind of a little shortcut into that. And here's what the formula says. He said if you're trying to do the limit as x goes to a for two functions being divided, one function over another, there's a shortcut to it. You can just take the derivative of the numerator and put that over the derivative of the denominator, and then try to plug in and evaluate the limit. This only works, though, in a couple situations. The two that you need to be concerned with is when we try to take the limit of the original problem and get 0 over 0, or if we get infinity over infinity. So this is what we're going to check for first. Looking for that pattern, 0 over 0 or infinity over infinity. That is called the indeterminate form. This is a shortcut to limits. It's easier if I just jump into some problems and show you guys. So let's go ahead and do that. So this first question. Now this goes way back into the beginning of calculus. Find the limit as x approaches 2. So what you normally would have done, you try to do these graphically if you can. That's the easiest way. I don't know what that graph looks like. I'm not spending the time to try to graph it. The next easy approach would be to plug in that 2. So I'm going to plug in a 2 for x, get 2 minus 2 over top of 2 squared minus 4, and then evaluate that. If this works out and I get a number, that's what the limit would be. So we get 2 minus 2 in the numerator is 0. 2 squared is 4, minus 4 is 0. You can't divide by 0. That's where the problem lies when you try to evaluate the limit. However, we got 0 in the numerator as well. Whenever you see this indeterminate form, 0 over 0, L'Hopital's rule should jump out at you. And his shortcut said, quite simply, all you have to do is take the derivative of the numerator, and then put that over the derivative of the denominator. So the derivative of x minus 2 is 1. The derivative of 1x is 1. Over the derivative of x squared minus 4, the derivative of x squared, the 2 goes down in front, the 4 drops off. And now let's try to evaluate this limit as x goes to 2. So then we're back to kind of where we were before. I could graph that one. That one's not that bad. But the easy approach is just to plug in and evaluate. So 1 over 2 times 2 is 1/4. That's the answer. I don't know how he figured that out, but it's a shortcut using an application of derivatives. If you're trying to evaluate the derivative and you get that divide by 0 error, but at the same time you get a 0 in the numerator, you get the indeterminate form. He says take the derivative over the derivative, then plug in and reevaluate. So that original answer is 1/4. Simple as that. This only applies when you get that indeterminate 0 over 0 or infinity over infinity indeterminate form. And you can thank L'Hopital for that shortcut. So let me just crank through a couple of these. Limit as x goes to 0, sine 5x over x. Initially, you would try to plug in 0. You're going to get that divide by 0 error. Okay, well, L'Hopital said there's a shortcut to that. You're still going to evaluate the limit, but you're going to take the derivative over top of the derivative. The derivative of sine of 5x. The derivative of sine is cosine. So it's cosine 5x. But there's a chain rule on this one. The 5x is a second function. The derivative of 5x is 5. Over top of the denominator's derivative. The derivative of x is 1. Okay, now try to plug in. So you would have 5 times cosine of 5 times 0 over 1. You're not getting that divide by 0 error anymore. 5 times 0 is 0. The cosine of 0 is 1. So it's 5 times 1, which equals 5. L'Hopital's shortcut. Whenever you get that 0 over 0 situation, so if I would have plugged in that 0 back in the beginning, I would have had sine of 5x, 5 times 0 is 0. Sine of 0 is 0. Over top of 0 is 0. That's my indeterminate form. Then I can go to everything in blue, which is L'Hopital's. This only works in this one situation, 0 over 0. And it's derivative over derivative. Now, there is a second shortcut to this one that I've already shown you guys. There's actually a flashcard. If you recall, we did the limit as x goes to 0 for sine x over x. That's a flashcard. You guys know that that's a 1. As soon as I put that 5 there, I showed you a shortcut to that. You just take 5 times 1 and you get 5. So you can actually use the flashcard on this one, or you can use L'Hopital's rule. Question 3. The limit as x goes to infinity. If you go and try to plug in infinity on this one, 5 times infinity squared minus 3 times infinity, that's infinity. In 7 times infinity squared plus 1 is infinity. You get infinity over infinity, which is the indeterminate form. Okay, so now we're going to jump to L'Hopital's rule. We're still going to evaluate the limit. But we're going to take the derivative of the numerator. 2 goes down the front, take 1 away, minus the derivative of 3x is 3. Over top of 7x squared's derivative, 14x. Okay, now let's try to plug in that infinity. So 10 times infinity minus 3 is still infinity. Over top of 14 times infinity is still infinity. We get the indeterminate form again. Check this out. I can do L'Hopital's again. Now I'm just going to do one more time. The derivative of 10x minus 3 is 10. The derivative of 14x is 14. Now plug in. There's no x's to plug in, so the limit is 10/14, which obviously you would reduce to 5 over 7. So the derivative, not derivative, excuse me, the limit as x goes to infinity, or 5x squared minus 3x over 7x plus 2, 5 over 7, using L'Hopital's rule. Thanks, Guillaume. One more thing with this question, though. Check this out. Do you remember back from your pre-calculus days? If I gave you just this function, you have a function over top of a function, and if you tried to graph that, it is equal heavy because there's a square in the top, a square in the bottom. Do you remember the rule for asymptotes, horizontal asymptotes, for when it was equal heavy? The rule was that it is the leading coefficients, 5/7. That rule for horizontal asymptotes applies to this problem, and you can do it with that technique as well. So now really you have multiple techniques to do this exact same question here. You can base it off of horizontal asymptotes because that's our limits are at infinity, only because it's infinity, or you could use L'Hopital's rule, or you could attempt to graph it. Last one. Limit as x goes to 1. Always try to plug in the 1 first. 1 cubed minus 1. 1 cubed is 1, minus 1 is 0. Spoiler alert, the bottom is going to be 0. 4x cubed, okay, 1 cubed is 1 times 4. Minus 1, minus 3. 4 minus 1 is 3, minus 3 is 0. Oh, 0 over 0. That is the indeterminate form. Then the bell needs to go off in your head. Try L'Hopital's rule whenever you have that happen. So we're still going to evaluate the limit as x goes to 1. Take the derivative of the numerator, 3x squared, over the derivative of the denominator. The derivative of 4x cubed is 12x squared, and then the derivative of negative x is negative 1. Okay, evaluate it. Plug in a 1. 1 squared is 3. 1 squared is 1 times 3 is 3. And then 12x squared. Okay, so 1 squared is 1 times 12 is 12. 12 minus 1 is 11. 3/11. So the original limit, 3/11. The cool thing about L'Hopital's rule on that second step, if I would have gotten the indeterminate form again, I would have done derivative over derivative again. And I keep doing it over and over until I finally do not get 0 over 0 and I get a number as an answer. As soon as you get a number as an answer, that's the answer to the limit. And that's it. L'Hopital's rule is that easy. The shortcut is to do derivative over derivative. So that'll save you a little bit of time with some multiple choice questions on APs when they're giving you limits to evaluate. Always try to graph it first if you can graph it, because that's pretty easy. Evaluate it second. If you can evaluate it and you get a number, that's your answer for the limit. If that doesn't work and you get 0 over 0 or infinity over infinity, then you're going to want to go with L'Hopital's rule. That's a nice little shortcut that he came up with. So hopefully you guys find that helpful. And you can go ahead and follow and try that worksheet online. And just one more thing, I got a special guest with me in the house. This is my nephew over here. He just learned some calculus. Did you learn anything?
No.
No, he didn't learn anything. He's only in geometry. One day he'll get there. All right, guys, we're out of here. See you later.
I knew you were going to do that.